In today's lesson, we'll be solving quadratics using the factoring method. Now let me remind you, we can already solve by looking at x-intercepts, both manually and on the calculator. But today we want to look at another method. This time we want to look at factoring. Our objectives for today will be to review basic factoring, then to introduce the zero product property, and to solve quadratic equations by using factoring. So let's begin with a basic factoring review. If your instructions are to factor each of the following, and then I give you this, let me remind you that your first step always in factoring is to look for a common factor, and if one exists, pull that out. So I want to begin by saying, what do these two terms have in common? Well, this one has an x in it, and this one has an x in it. So they have in common at least one x. Well, it turns out that that's what I can pull out then. So when I pull out the x, I'm left with x minus 6. Let me remind you that you'll know you have factored correctly because you can always put it back together and get what you started with. So in this case, the correct factorization is x times x minus 6. Let's go a step further now. What if this time I have a trinomial, meaning I have three terms? The first thing I look for is still a common factor. Is there anything they all three have in common? And the answer to that is no. So if that's the case, then most of you will remember our next step will be to do this right here, and then you'll start filling in the blanks. Remember, x's go here. Because this is plus, it tells us the signs will match, and this tells us they will both be plus. So I know that both the signs will be plus, and then I'll look for two numbers that multiply together to give me 6 and add together to give me 5. So we would look for 2 and 3. So it is equal to x plus 2 times x plus 3. Let's continue now with another example. This time I still have a trinomial and I have x squared minus 8x plus 7. Once again, there is no common factor, so I would begin with this step right here. I know x's go here. This time I know that the signs match and they are both negative. So there they are. And now I'm looking for two numbers that multiply together to give me 7 and add together to give me 8. Well, there's 7 and 1. So I get x minus 7, x minus 1. Let's do another one. The difference this time is I want you to notice that this is negative. Once again, there is no common factor, and so this is my first step. I still know those x's go right there. But this time, because this is negative, I know that the signs will be opposites, or one of each. I'm now looking for two numbers that multiply together to give me a negative 12 and add together to give me 1. But please remember that they must be opposite signs. Well, the two that pop into your mind should be 4 and 3. If I multiply those together, I get a 12. And if I add those together, if this one were positive and this one were negative, then I would get my positive 1. So my two choices here will be x minus 3 and x plus 4. Or as I wrote it here, notice that the order doesn't matter. I actually wrote x plus 4 times x minus 3. Those are basically the same answer. It does matter where those signs are. The negative is still with the 3 and the positive is still with the 4. Let's go to the next one. I have 2x squared plus 10x minus 12. Remember, we always ask, is there a common factor? Well, this time there is a common factor. What is it? 2. Well, if I pull out that 2, what I'm left with is 2 times x squared plus 5x minus 6. And then I need to do exactly that same step again. Remember, the 2 will just hang out here and be part of the answer. But here's your next step. So it's x's. This tells me the signs are opposite. And then I'm looking for two numbers that multiply together will give me 6 and add together to give me 5, remembering that their signs are opposite. Well, the two that should pop into your mind are 6 and negative 1. If I multiply those together, I get a negative 6. If I add those together, I get a positive 5. So the 6 should be positive and the 1 should be negative. So we get 2 times x plus 6 times x minus 1. And the last type of factoring we want to look at today is what we call the difference of two squares. If you look at this, what we actually have here is something here that is a perfect square, where you have x times x gives you x squared, and something here that is a perfect square. 3 times 3 would give you 9. Anytime that happens, you will always factor this into two identical factors with opposite signs, meaning you'll use the square here, that would give you the x squared, and this will give you the 9. If you actually took the time to FOIL this together, you would find that you get x squared, then you would get a positive 3x and a negative 3x, so that's where that middle term goes, and then a minus 9. So if you FOIL it, it really does work. But anytime you have the difference of two squares, it will factor into two factors that look exactly the same except for their signs. Let's look at another one now that is also the difference of two squares. 16x squared minus 25. Well, once again, what you should see here is that this is a perfect square. What I want to know is what times itself would give me 16x squared, and the answer is 4x. Over here, what times itself would give me 25, and I see that it's a 5. So what I'm going to have for an answer here is 4x minus 5 and 4x plus 5. If you took the time to FOIL it, you would see that you do get 16x squared minus 25. Now that's just a quick review of factoring, and you may need to spend some more time practicing if that doesn't come back to you pretty quickly. There are lots of other problems that we can do by factoring, but I will tell you that we're going to use factoring as a method for solving a quadratic equation. If the factoring is more difficult than this, you may want to simply choose another method. So let's go with a basic factoring, and we'll solve quadratics that involve basic factoring. So let's go to that. Before we can solve quadratics using factoring, we'll need to talk about the zero product property. Now, I've worked very hard at coming up with a way to explain this to you, and the best I've come up with is another one of my corny games. I used my imagination to come up with the name. It's called Fill in the Blank. If I gave you this line and I ask you, blank times 4 is equal to 0, I need you to tell me what you could put into the blank. Well, hopefully you're telling me that you would put a 0 there. Is there anything else you could plug in there? Well, there's not, so it would turn out that 0 is the right answer there. I know that was fun, so let's try it again. We're going to play fill in the blank again, and this time I ask you 3 times something is equal to 0, and what would you tell me the something is this time? Well, hopefully once again you're going to tell me it's 0. Now what I want to make sure you understand is this. This is an example of the principle of zero products. So let me talk to you a little bit about what this means. While this looks very simple, and many of you probably told me what to put in the blanks, I need you to understand the significance of what this means. If you'll bear with me for a minute, we'll visit Dr. Seuss and we'll talk about thing 1 and thing 2. What this property says is this: if I have two things multiplied together that equal 0, then either thing 1 had to be 0 or thing 2 had to be 0. Well, in the first example, it was thing 1, and I got 0 for an answer. In the second example, I had two things multiplied together. I got 0 for an answer, and this time it was the second thing that was 0. But what I need you to take from this is this thought. When I have two factors multiplied together and the answer is 0, then one of the factors had to be a 0. That's the only way it can happen. Any other number I put in here doesn't give me 0 for an answer over here. So if two things are multiplied together and I get 0 for an answer, one of the things had to be a 0. Now what we're going to do is we're going to take that and use that, believe it or not, in solving quadratic equations. I want to start this time with a quadratic equation. And I want to ask you this question. Could you factor the left side of this for me? Well, hopefully you can. There is no common factor, so our first step is this. We know the x's. Can you tell me about the signs? One of each. And then I need the numbers, a +5 and a -1. Okay, that looks a little nicer than my hen scratching, so let's keep going now. Here's what I need you to see. Remember, these two things are multiplied together right here. Remember a minute ago we talked about thing 1 and thing 2? If you have two things, factor 1 and factor 2, and they're multiplied together, which these are, and it's equal to 0, then the only way that could happen would be for one of those things to be a 0. Well, think with me for just a minute and tell me, what number could I put right here so that when I added it to 5, this whole piece right here would become a 0? Well, the answer is -5. A -5 plus a +5 would be 0. And if you didn't come up with that, let me show you the way you can calculate it. You just take this factor, set it equal to 0, and then solve. When you subtract 5 from both sides, you get x is equal to -5. That's one of your solutions. But there's another one. I will also have a true statement when this piece is equal to 0. So let's take it, set it equal to 0, and solve as well. When I add 1 to both sides, I get x is equal to 1, and there's my other solution. And what I've done is I have solved a quadratic equation by factoring. If I can factor it and set each factor equal to 0, I can get my two answers. Now let me make sure you understand something. I could have entered y is equal to x squared plus 4x minus 5 on my calculator and looked for the x-intercepts, and by the way, this is what I would get, a -5 and a +1. What we're looking at today is another method, factoring, of doing this. It doesn't mean this method is wrong or it won't work. It simply means I've got another way to get there. I also want to point out for you that it is critical that you notice that this only works if this is equal to 0. Remember, the zero product property only worked because you told me thing 1 times thing 2 had to be equal to 0. So in order for this to work, this side must be equal to 0. And if it's not, you'll need to make that happen. Let's look at another example. This time I want you to notice it is not equal to 0. But can I make that happen? Well, if I simply add 1 to both sides, I would get 2x squared plus 2x minus 12 is equal to 0. I'm now in a position that I could factor this. If you can, you should stop the video now, factor this one, and get your solutions. If not, then follow along with me. You should have factored out a 2, and that would give you 2 times x squared plus x minus 6 is equal to 0. Next, we need to say, can I still factor this piece in here? And the answer is yes, I can. I would get 2 times x plus 3 times x minus 2. Remember, I was looking for two things that multiply together to give me a -6, 3 and a -2, and add together to give me a +1, 3 and a -2. Once I make it to right here, I simply take each of those factors and set them equal to 0. So it's x plus 3 is equal to 0. I subtract 3 from both sides, and I get x is equal to -3. That's one of my solutions. I then take the other factor, x minus 2. I add 2 to both sides, and I get x is equal to 2. So those are my two solutions for the quadratic equation, 2x squared plus 2x minus 13 is equal to a -1. If you want to try that and plug them in, you should be able to see that both of these answers do indeed work. By the way, if you graphed right here as well and looked for the zeros, you would find that they are right here and right here. I want you to notice, you see this is -3? Well, that's exactly what that is. And this one is +2, and that's exactly what this side is here. So it's not that we get different answers. It's just another way of getting the same answers. Let's look at another example. This time I have x squared plus 3x plus 5 is equal to 0. First question I would ask is there a common factor? There's not, so I would start right here. I would see x and x. Tell me about the signs. They're both pluses. I'm needing two numbers that multiply together will give me 5. Well, to multiply together, the only way I can get a 5 is 5 times 1. But is there any way that those two are ever going to add together to give me a 3? The answer is no, they're not. So that means I cannot factor this problem. And the reason I've done this is because I want you to see you need another method. There are problems that factoring will not work on, and this is one of them. So I don't want it to throw you a curve when you hit one and you say, gosh, that won't factor. You just need to back up and punt by using a different method. Well, hopefully now you can solve some of these quadratic equations by factoring. So let me leave you with my thought for the day. A fanatic is one who can't change his mind and won't change the subject. I'll see you again soon. Bye-bye.